In section 8.6, we're going to be looking at application problems with distance, rate, and time problems, interest problems, and then an application of the average problems. When solving problems, tables can be useful to help organize and set up an equation. In this section, tables are introduced for two particular problem types, our distance, rate, and time problems and the interest problems. Both of these problems involve using some information from two equations to solve for unknown variables. So here's an example of our distance, rate, time problems. It says, use the equation d equals r times t. Word problems will describe two situations or two parts of the same situation. This information will be used to set up an equation, and they're going to walk us through using this table. Now, when you're doing your homework, even if they don't give you a table like this, it will be really helpful for you to create your own table to help you solve these problems. A motorist averaged 45 miles per hour for the first part of the trip and 54 miles per hour for the last part of the trip. If the total trip was 303 miles and it took 6 hours, how long did each part of the trip take the motorist? Sounds impossible, I know, but again, we're going to walk through it, we're going to use this chart, and we'll see how we have exactly all the information that we need to solve this. So first it asks, does the problem statement give you the values for the rates, the times, or the distances for both parts of the trip? And so we had a miles per hour for the first part and miles per hour for the second part, so it gave us the rates for both. And then it asks us to fill that in. And so for our first part of the trip, our rate was 45 miles per hour. And for the last part of our trip, it was 54 miles per hour. The problem is asking for the time for each part of the trip. Fill in the time column of the table by using the variable t to represent the time for the first part of the trip. So we don't know how long it's going to take, so let's assign it t. Now, the time for the last part of the trip will equal the difference between the first part of the trip and the total time. So if we assigned the first one with t, we know the total was 6 hours, and so the distance or the time that it's going to take for the second part of the trip is whatever's left over when we take our total of 6 minus that first part of the trip, which again, we represented with a t. Now, if you notice on the charts, they put a little dot here, which represents your multiplication. Again, they didn't put an x because they don't want you to think of a variable x. And then they have an equal sign, because remember, distance, which is in the last, equals rate times time, which we have as the first two. So for our second part, now that we've filled in the first two columns, is to just multiply those two and put our answers here. So 45 times t will be 45t, and 54 times 6 minus t, let's put that just in parentheses. Instead of distributing, we'll just leave it that way for now. We'll distribute when we go to solve the problem. And so now we have everything that we need to fill out in this chart. I wish they gave you another spot down here, because I like to be able to have next to my chart what is going on with things. Because the only other piece of information that they told us that we haven't used yet is the total trip was 303 miles. And so what that's telling me is it's the sum of the first part of the trip plus the second part of the trip. And so you can see here is your equation that you need to solve. And we're going to do that next. Since I don't have a whole lot of room on this page, let's just go ahead and solve that on this one, and then we'll fill in wherever we need to answer the questions that they give us. But again, what we know now is that the total distance for the first part of the trip is represented as 45 miles per hour times the time that it takes us. And we're adding to it the part from our second, which is 54 miles per hour times the difference of a total of 6 hours minus the time from the first part, and the sum of those distances need to be 303 miles. So now it's an equation that you know how to solve. We've worked with these kinds before. So now we can distribute and get rid of our parentheses. So we're going to have 45t dropping down plus, and then 54 times 6 will give us 324. And 54 times a minus t, or a negative 1t, will give us minus 54t. And that equals 303. Okay, now let's combine like terms. We have 45 minus 54 for our terms with the t, and that will give us negative 9 when we combine them. So negative 9t plus 324 equals the 303. Now let's get rid of our adding 324 by subtracting it from both sides. So we're left with negative 9 times t on the left-hand side and negative 21 on the right-hand side. And so when we divide both sides by negative 21, I'm sorry, we divide both sides by negative 9, we get t equals negative 21 over negative 9, which simplifies down to 7 over 3. And normally we don't talk in time as in improper fractions. Oh, I went 7/3 of distance. Now we usually change it to a mixed number. And so if we do that, 3 goes into 7 twice with 1 left over. So 2 1/3 hours, that represents the t. Okay. So now let's fill all this good stuff into the questions that you have in your workbook. So again, the sum of, we now have the terms to represent the distance. What is the total distance of the trip? And that would be the 303 miles. So the total equals the distance of the trip. We already wrote our equation, but let's copy it here. So we had 45t plus, space there to help see that, plus 54 times 6 minus t, and that will equal 303 miles. And so we solved it for t, which represents the first leg's time. So t we saw was 2 1/3 hours. So remember, the time for the last part of the trip was t minus 6. We filled that in the charts. Or sorry, 6 minus t. So we're going to do 6 minus 2 1/3 to give us, that looks like 21/3, doesn't it? I'm sorry, it's very sloppy. But that would give us 3 2/3 hours for the second part. So now it wants us to determine the length of each. So remember, distance equals rate times time. We already filled in those numbers, so now let's just do that multiplication. So 45 times our t of 2 1/3 for the first part of our trip would give us a total of 105 miles. Our second part of the trip, we were going 54 miles an hour. And we subtracted to get 3 2/3, which puts us at a distance of 198 miles for that leg. And so it's asking us, do these add up to 303? Do we get what we were supposed to get? So 105 plus 198. And if we add them together, yes, we get the 303 miles we were told was being traveled. And so we checked our work and saw that we were right. Here's an example doing the same thing with our interest rate equals principal times rate times time. And notice here it says for these problems, we're always going to use 1 year. So that's why there's no time in your chart, because anything times 1 stays the same. So your questions will always have for a year, for 1 year. So you don't have to worry about that part of it. Amanda invests $25,000 for a year in a bond fund that pays 5% interest and a stock fund that pays 6% interest. The annual return or interest on the 5% exceeds the annual return on the 6% by $40. How much did she invest in each rate? So again, I don't know. It's scary, but let's walk through it and fill in our chart, because the chart really helps. And so what we can see for both is that we're given the percentages, which is the rate. And so if we fill those into our chart, the stock fund is 6%. And I think they really wanted that to be listed second, but their words will follow in the chart because 0.05 was given first. But that says in the bond fund that pays 5% interest. So we make sure we put them in the right column. And so now we know that the $25,000 is the total. So just like before with the total of 6 hours, we're going to assign one of these funds a letter, and the other one is going to be the total minus that letter. That's always going to be the setup that you're going to have for these problems. In this, it asks us to use P for our unknown for principal, and it says to represent the P for the bond fund. And so again, that means that here we're going to have P. So the stock fund then has to be the total, which was $25,000 minus whatever we put in the bond fund. And that'll tell us how much we have in each. The interest rate, our last column, is just the multiplication of the first two. So our 0.06, 0.06, here it goes. It's multiplied by our 25,000 minus P. And our interest rate of 0.05 gets multiplied to our P. Now, what's different here is that when we go to see how we're comparing them down here, again, I like to put that extra information down here, notice it says that the one interest exceeds the other by $40. And it says the 5% interest, so the 5% is going to be the bigger number. So this one was the bigger. And so bigger minus smaller, we're going to subtract and get $40 difference. So again, everything that I need to know to write my equation, I just put over here by adding that little bit of extra information at the end. And so again, it told us that the 0.05 P was the value that exceeded, which means was bigger than the stock fund, 0.06, the 25,000 minus P. The difference is $40. So there's our equation. Okay. Now that we have an equation, we know how to solve it. So, first thing you do to solve is you get rid of the parentheses by distributing. So we have 0.05. Let me type this again, because it's easier for you to read it the more I can type. So we have 0.05p minus, and then when we multiply our 0.06 times our 25,000, we get 1,500 or 1,500. Notice now we have negative 0.06 times negative p. Two negatives make a positive, so we'll have plus 0.06p equaling $40. And then we can combine like terms. We have a 0.05 and a 0.06p, so 5 cents and 6 cents would be 11 cents. And again, it's not really money, but it just helps me add better. The 0.11p minus the 1,500 equals the $40 difference. So now to continue to solve it, we will add the $1,500 to both sides. And we're going to get our 0.11p by itself, and that equals 1,540. And so our last step is to divide off the 0.11. So p will be by itself. And so we get a p value, which is how much is invested in the bond fund, of $11,000. Oh, I'm sorry, $14,000. I was looking at the answer for the other one, which is what we get when we subtract. So again, P equals 14,000, and then we can subtract to get the stock fund, but we'll wait and do that last step when we fill out our questions. Okay. And so our equation that we built, again, was a 0.05 P subtract the 0.06 times the 25,000 minus P, and the difference equals $40. And so we had found that P represents the $14,000, and that's the amount invested in our, and that's supposed to be an and symbol, 5% interest. And so our total was 25,000. We're subtracting off 14,000, and that's where that 11,000 comes in. So we know that 11,000 was invested at, that was a little bit better, the 6%. Now, when you're working through your Hawks and quizzes and tests for these types of problems, when you're dealing with the money, you are going to get even numbers, even dollar numbers. If you come up with an answer that you have to round and it's crazy, like $462.19, you made a mistake. They're going to come out nice, even numbers for you. So the third problem is an average problem, but they're going to change it up by one of the pieces of data being missing, not just finding the average. They're going to give us the average. And so we're going to have to solve them by kind of picking away the problem, and it's similar to what we did during the last section with our reworking the formulas kind of idea. And I don't mean that to scare you. I'm just saying that are unknown is kind of buried in the problem when we started. Which, once you have a few problems practiced, I think you're going to find them actually not to be bad. I think they're kind of easy once you have some practice with them. This example says Kaylee needs an exam average of 82 to pass her history course. All 5 of her exams are weighted equally, and they're worth 100 points each. She has the following scores on the exam so far: 62, 90, 89, and 80. What does she need to earn on the final exam to have an average of 82 for the course? So what do we know about averages? We add them all up and divide by how many numbers there are. And so it says let E represents that final exam score. So we would add the 62, we know, the 90, the 89, the 80, and the final test, which you still haven't taken yet, E, divide that by how many scores that we have, which will give us a total of 5 scores, and that will equal the total average of 82. I think I'm getting ahead of myself a little bit because, again, what they're saying is that E is the final exam score. And so the equation is what they're actually asking for in the next part, right? Next question, to find the average of the exam scores. And so again, we're adding all up and dividing by 5, even though one we have to use a variable. And so creating an equation by setting the expression equal to the average. Again, I already did that, equaling 82. So let's go ahead and simplify that, because if we add the 4 known numbers, we get 321 so far. We add the exam and divide by 5, we get 82. So now they want us to solve it. So again, we had 321 plus the E divided by 5, and that equals 82. Well, normally we were getting rid of addition and subtraction first, but notice these two parts are together on the numerator of a fraction. So we think of fractions as dividing. So to get rid of that 5, so we can separate them, we need to multiply by 5. So what that tells us is that the 321 plus the exam score needs to equal a total of 410 points. And so again, 5 times the 82 tells us how many points she needs total to get the 82%, and we'll subtract off the points that she already has, which are 321 points. And so we see that on her exam, she needs to get an 89. So Kaylee needs an 89 on the final exam to have an average of 82. Now it says, suppose the final exam counted as double. How is that going to change the problem? Well, we know she already has the 321 points. That's not going to change. But double means times 2, so we would do 2 exam scores. And now instead of 6 scores total, since that one's worth 2, instead of 5 total, we'll have 6 total. But we still want to get an average of 82. So again, what we're still going to do is multiply both sides by the 6. And so that will leave us with 321 plus 2e, so it was in our numerator. But now instead of 82 times 5, it's 82 times 6. And so that gives us a total of 492 points. And then when we subtract the 321, we see that 2 times her exam score would need to equal 171 points. And when we divide that by 2, we see that she needs an 85.5. to get that. So compare the parts of those answers. Which scenario does she need the higher grade on the final? She would need a higher percent for part B. And just like in averaging anything, the more test scores there are, the less effect a lower score makes. So again, that lower score in this case would be 62. So the more scores that you average together, the less they're going to be affected, and the less you would then therefore need to average out from the other tests when you do the better test scores on. I think I'm not making sense, but hopefully you understand what I'm trying to say. So you have a couple practice problems here for you to do. Notice they're just giving you examples of working through equations and solving for x. 7 is like the problem that we just did with an unknown score. And so when you work through these and are ready to continue on with the story problems, then you can move forward. Achilles is racing a tortoise and gives him a 2-hour head start. The tortoise runs at a pace of 10 miles per hour and Achilles runs at a pace of 25 miles per hour. How long will it take Achilles to catch up to the tortoise? So let's look at filling in our chart first. It says to let the variable t represent the amount of time that the tortoise has traveled. So let's put that first. Time for the tortoise is t. Now we are given somewhat of a comparison. Our comparison says that the tortoise is given a 2-hour head start. So that means that the tortoise is running 2 hours longer, has already been running 2 hours before Achilles starts. So that means Achilles is running 2 hours less. And so Achilles we will represent as t minus 2. And we know the speed that they run. The tortoise runs at a rate of 10 miles per hour. And Achilles runs at a rate of 25 miles per hour. So now we know the distance column because we multiply the rate times the time to get our distance. So we have 10t for the tortoise, and we have 25 times the difference of t minus 2 for Achilles. And so now when we look at the total distance, they're giving us, again, something a little bit different. It says, how long will it take for them to catch up? So they want the spot where Achilles' distance is the same as the tortoise's distance. And so here, we're not adding or subtracting like we've done before. We want them equal to each other. And that's what it tells us in part B. When Achilles catches up to the tortoise, they will have traveled the same distance. Set up a linear equation. So again, the distance for the tortoise, which we represent as 10t, has to be the same amount as the Achilles distance, which is 25 times the difference of t minus 2. So that is our equation. And so now we need to solve it. Let's again just go ahead and solve it here, and then we'll put our answer in for the next spot. So our first line of business would be to get rid of our parentheses by distributing. And so when we do that, we will get 10t equals 25t minus 50. Okay. So now we have to move all of the t's to one side and anything that's not a t to the other. Since we only have t's on the left, we're going to move our 25t that way. And we're going to subtract 25t from both sides. So when we do that, what is left is a negative 15t equals negative 50. Don't forget that minus in front of that 50. That has to be brought down with it. So now what we need to do is get rid of the multiplication of negative 15 through division of negative 15. So we're left with 1t. And then we can simplify negative 50 over negative 15 to 10/3. And again, we usually don't talk about time as improper fractions, so let's change it to a mixed number. So we'll have 3 1/3 hours as t, which represents the tortoise's time. So we already solved it. T equals 3 1/3 hours. Now, how long is Achilles running? How long does it take him? Remember, he ran 2 hours less. So we'll subtract off the 2-hour head start. And he was only running for 1 1/3 hour. Now, if the race was 35 miles long, will Achilles pass the tortoise before crossing the finish line? So we need to see if he was running more than or less than 35 miles. So we know our distance equals rate times time. So the distance that the tortoise ran equals his rate of 25 miles per hour times the time of 1 1/3 hours. So that tells us that the distance that he has run is 33 1/3 miles. So that means there's still a little bit of distance left in the race, actually 1 2/3 miles, and we know he's running faster, so he will win the race. But yes, he passes. And our work supporting it is showing the distance that he ran to compare it to the distance that they said the race is. Let's look at another story problem. Savannah invests $3,600 per year into her retirement account, a portion of which is a contribution match from her employer. Savannah invites the employer to match a high-risk fund that averages a return of 8%. So let's go ahead and put that in, 0.08. And the rest in the low-risk account that averages a return of 4%, so 0.04. She wants to earn a total of 198, so we're going to be adding our two interests to get 198 for our formula. And how much should she invest in each fund? So now the only piece we need to know is here, let the variable P represent the high risk fund. And so we'll plug in P for our principal there. So that means the low risk fund is the difference between the $3,600 that she puts in, subtract that amount from the high risk fund labeled as P. So now we can fill in our interest columns. 0.08P represents the amount of money earned in the high interest fund. And then 0.04 times the difference between 3,600 and P is the amount of money invested in the low risk fund. And again, we know the total has to be $198. So there's our equation, 0.08P plus 0.04 parentheses 3,600 minus P equals 198. Okay, so let's keep working it to solve it. First things first, we'll get rid of our parentheses. So we'll distribute our 0.04 through the parentheses. So the 0.08 stays the same. And then 0.04 times the 3,600 will give us 144. So then that's minus 0.04P equals 198. Okay. Next step would be to combine like terms. On the left, we have 0.08 minus 0.04 for our P, so we have 0.04 left when we subtract. So we still have plus 144 equals 198. Now we'll subtract 144 from both sides because we already have all our P's on the left. And so when we do that, we get 0.04 P equals 54. And so our last step would be to get rid of our decimal, our coefficient of 0.04 by dividing that from both sides. And we see that our P, which represents the principal, the amount invested in the high risk fund, is 1,350. And so, how much should be invested in each? Well, we know part of it. We have 1,350 in the high stakes. So let's just label it at the 8% rate. And then we'll subtract. We had the 3,600. Let me type that. It goes quicker. 3,600 minus the 1,350 gives us our low risk fund of 2,250. And that's at the 4% rate. Now it wants us to check our work to show that this is working for us. Verify that the investing amounts from Part D gives you a total of 198. So we want to see what we get. So again, if we look at our chart, we have the interest equals principal times rate. Remember, the formula actually has times time, but we're looking at 1 year. And so it would have been times 1, which we can just ignore for this purposes, because anything times 1 stays the same. And so we had 0.08% for 1,350 of the amount, plus 0.04% for the balance of 2,250, and that is supposed to equal $198. So let's see what we get. The 0.08 times 1,350 gives us $108. And then the 0.04 times 2250 gives us $90. And so when we add that, we do get 198 equals 198. So our answer checks out. We do have the right amounts. 2 more to go. Kevin consulted a dietitian who told him to consume an average of 2,100 calories per day based on his age, current weight, activity level, and weight goals. Kevin kept track of his calorie intake for several days. He consumed, we just won't read all that right now, those calories on those days. How many calories would he need to consume on Friday to have an average calorie intake of 2,100 for the 5 days? So this is like our average that we were doing with the test scores, but now we're using calories. And so when we set up an equation, I'll type some of this, we're going to add up the calories consumed each day. And so we had 2050 on Monday, plus 2,200 on Tuesday, plus 2,300 on Wednesday, plus 2,400 on Thursday, plus we need to find Fridays. They tell us to use X. And then we will divide that all by how many days? 5? Ooh, that's bad. And then it says that average needs to be 2,100. So solve the equation. So remember, our first step is to get rid of the divide by. So we're going to multiply both sides by 5. And so when we do that, let's go ahead and add up all of our calories up until Friday. We can't add Fridays yet because that's what we're trying to find. And so we add those all up, we get 8,950. And we're adding Friday's calories to that. And it needs to be a total of 10,500 calories. And so then all we have to do is subtract the total that we have so far, which is 8,950. And we see that he can consume 1,550 calories. That's how many calories he has left for Friday to be able to stay within his goal. It is recommended that active men consume more than 1,500 calories per day to avoid triggering a starvation mode in the body. Can Kevin stay above this calorie amount and meet his recommended average for the 5 days? Well, he beats it by 50, so yes, he can. And do you think it's a smart way for Kevin to adjust his calorie intake? If not, what are some alternatives? Well, I say no, because he's really going willy-nilly with his calories the other days, and most days are above the recommended average, because we had Tuesday, Wednesday, and Thursday all higher than what he was supposed to be taking in on average. And so he needs to target himself for the 2,100 calories each day. That would be my advice, because what if he goes really crazy and then he only has like 400 calories left for Friday? Last story problem. Robin's refurbished Rex purchased a used car for $2,850 for the upcoming Labor Day sale. The car dealership would like to offer a 5% discount off the posted selling price, but they would still like to make a 40% profit. What price should the car dealership advertise for the car? So we're kind of seeing a little bit behind the scenes on what car dealers do to try and trick us into believing that we're getting a sale. So first, use the purchase price of the car to determine how much of profit 40% would be. So they want to make 40% off of what they bought the car for. They bought the car for $2,850. So they want to make $1,140 from the sale of this car. Now it says use the variable X to represent the actual selling price of the car. Write an expression to represent the selling price of the car after a 5% discount. We've done some discount problems before. Remember when we're looking at selling price, the 5% discount means that we're paying 95%. So we won't use 5% in our equation. We're going to use that 95%. And so 95% of whatever that sticker price is, that what they're saying the cost is, plus the $1,140 that they want to make on the car. Oh, sorry. Subtract off what they paid for the car, $2,850, needs to equal what they want to get out of it, which is $1,140. I almost switched the two numbers around. And so I got ahead of myself, didn't I? Because it reminded me down here, selling price minus cost equals profit. So they just wanted here the selling price of 0.95x. And then it's down here that they wanted the other part. So let's just copy it again. So 0.95x minus the 2850 equals 1140. And so now we have to solve it. So this is a fairly easy equation to solve. We just have two steps to do. Our first step will be to add the 2,850 and so when we do that, we are left with 0.95x on the left, and we are left with 39.90 on the right. And so now we need to divide off the 0.95 and we get an answer of x equals 4,200. And so what does this mean? In a complete sentence, it means that Robin's Rex should sell car for $4,200 to make a 40% profit after a 5% sale. As always, if you have any questions while you're working through your problems on Hawks, don't hesitate to send me an email. Otherwise, I'll see you next time.